We are honored to have Dave Taylor W8AAS join us tonight. He will talk to us about amateur radio on the International Space Station, otherwise known as ARIS. Dave is the U.S. Operations Manager for ARIS and its International Delegate. So welcome, Dave. Thanks for joining us. And now it's over to you.
There we go. I'm getting myself switched over here. So, and that should have that out to you.
Yes.
And double checking audio settings, got just the way I want them. I'll move over so I can see what's going out. Great. As I said, good evening. Well, as Alex said, I am Dave Taylor, W8AAS. U.S. Operations Manager is a little out of date now, but I am one of the 2 United States delegates to the ARIS International Working Group that runs the program. And well, I don't know why Zoom puts that label right over my slide. Okay, overall, this is what ARIS does. We're basically an education organization promoting STEM, which is STEAM with arts as well, to kids around the world, teaching them about space and amateur radio and electronics and all the things that relate to those fields. We usually do about anywhere from 60 to 120 contacts a year worldwide. ARIS is set up as a working group, which is an informal, or at least not a legal organization. It was formed at NASA's request to give them one central point to talk to about all amateur radio operations on space station, back when they invited us to participate on board because they liked what ham radio had done on the space shuttle. There are 12 delegates internationally, and we get together along with our officers monthly on telecons, and then every year or so for an international face-to-face meeting, which is coming up in about 2 weeks. But because the working group is not formal, we used to use existing nonprofit corporations, AMSAT here in the United States, to accept our donations and sign papers with agreements with NASA or whoever. That was becoming awkward, so a while back the US team incorporated in its own right so that we can now take donations and sign grants and go out and solicit monies directly. And we don't confuse people by having another name in there. Some of our major supporters, of course, American Radio Relay League and AMSAT, is the delegates that run ARIS are appointed in each country by those organizations, the National Amateur Radio Group and the AMSAT group. So I am the AMSAT delegate for North America, or not actually for just the United States. There's also an AMSAT appointed delegate for Canada. We work with SCAN, which is a part of NASA. They handle all of the space communications, the Deep Space Network, the TDRS satellites, and any kind of communications from ground to spacecraft or spacecraft to spacecraft. So we have a lot in common with them. And US National Lab is a company that has a contract with NASA to run the education and mostly the research that goes on in the US segment of the space station. As I said, we're primarily an education group working with kids to help them grow up to replace us and the things we do. We also do hardware development for the radios on the space station and spaceflight operations from point of operating the radios. We do some of our contacts through telebridge stations, which is basically a phone link. And that picture there on the right is one of our telebridge stations. That's Shane down in the Queensland area of Australia. Really nice shack. One of the things we have to do for our sponsors is collect numbers to show how the program is getting along and help them justify the support that they give us. So we keep a lot of statistics and always show that off in something. One of the interesting things I like to see is the maps. We've done contacts in every state except South Dakota. We keep working on them, but never find anybody there. We've also, and can't see it too clearly, but we've also done a contact in Puerto Rico, contacts in Washington, DC. And we did a contact with a school down at Guantanamo a few years back. That's 70 countries overall, all over the world. And here I wanted to give you a quick idea of what an ARIS contact is like for the students. This is a school down in Virginia where they set up on the stage, which we do for about 2/3 of our contacts in the United States. So the kids can see what's happening. They've got antennas outside, radios here. They're in the auditorium. This is about 40 seconds long. It will give the introduction, and then you'll hear one question and answer.
Farmwell Station Middle School, welcome aboard the International Space Station. I've got you loud and clear.
Hi, my name is Alejandro, and my question is, can you grow plants in space? Over.
Alejandro, this is a very timely question. In fact, tomorrow we are going to be harvesting some lettuce that we've been growing on board the International Space Station for the last 4 weeks, and it will be food that we can actually eat. And we've been testing how different lighting conditions and fertilizer can help us to grow plants on board the space station for long-term space voyages out to Mars and beyond.
So that's kind of what it's like when the kids get to ask an astronaut a question and hear an answer. It's really nice these days. There used to be our contacts would take place, but pretty much mostly people didn't hear them. But with streaming becoming more and more common in the world, schools are streaming things. Now pretty much every contact is streamed by the school on ARIS YouTube channel, or sometimes both. So it becomes much more accessible to the world.
Farmwell.
Let's see, come on now, forward. There we go. It is an international group. ARIS divides the world into 5 regions based on the 5 space agencies that help work on the ISS. So we get people from the US region, of course, but also Japan, Germany. Well, Germany is also with Italy, the European Space Agency. We get Russia and Canada. And everybody gets up there and does things at one time or another. And the contacts take place all over the world. I mentioned the places we've done in the US, but here's some interesting places. Nunavut in Canada, if you haven't heard of it, is an Inuit community way, way north. It takes people like a day to fly up on a private plane to get radios set up there for them. And we've even done a contact. There is one school down in Antarctica at an Argentinian base, and we did a contact with them last year. It was really, really neat to see everybody in the audience wearing bright red parkas. The contact is sort of the highlight. It's the apple that we dangle in front of people. As part of doing a contact, schools and any educational group, summer camps, scout groups, whatever, do a lot of pre-contact education, teaching kids all sorts of things. We work with amateur radio clubs or individuals in the area where the group is, where the contact is being held. And they will usually go to the school and help teach a few things, demonstrate radios, pretty much everything. This is a very intensive STEM project, not just a 10-minute contact. When we do contacts, we've got 3 different ways of doing it. The one that we like best is setting up radios directly at the school. That's dependent on the local club, whether they have the means to do that. If that won't work, or if it doesn't work for other reasons, like some schools are in a place where their day barely matches the astronauts' day. Astronauts work on Greenwich Mean Time. So it becomes necessary to use what we've always called a telebridge. That's basically a phone patch. We connect the school to one of our telebridge stations around the world and run the contact that way. At the start of the pandemic, we found that wasn't working because that assumed that all the kids were at one spot. So we started experimenting with computer connections, Zoom links and other meeting platforms so that each student could be at their home, and we'd all link together. We called that a multi-point telebridge just to make it clear that it was being handled in a different way, but that's really becoming very common now. It works better. So that's kind of our standard telebridge these days. For the direct contacts, or what you might think when the station comes over the horizon, you get to talk to them. That's nominally 10 minutes, a little less if they're passing very low to the horizon, but we try to keep them up at least 30 degrees to have a good signal for the kids. And at that point, it's usually 10 minutes. Sometimes if the station has reboosted recently, it will be a little higher and we might even get 11. And the telebridge, that's also a bit of an old map. Some of our stations retired. We've only got 1 station in Australia right now. And the west coast of the US doesn't have anybody at the moment. We're between stations there. But it's a pretty well dispersed map, and it helps a lot with giving us different options for the timing. Scheduling a contact is really tricky because you've got the time the kids are available, the time the astronauts are available, the time the space station will be in the right place, close to a ground station. And things won't be happening that keep us off the air. Like, if there's an EVA going on a day, our radios go off. A lot of safety constraints involved in working on the space station. And this is the multi-point slide that we were using to educate people about that. Basically, still a phone patch going to lots of different places. This is some pictures from one of the contacts we've done. The Copernic Observatory up in New York does a lot of active summer camps. And the person who runs the observatory is an active ham. So he's always been interested in this. And in fact, during the pandemic, when some of our stations were closed because of the pandemic, he took over and helped us keep things going. We work with as many as wide a range of students as we can. And these are the metrics, again, that we keep for our sponsors. NASA in particular is concerned about that because they have to report to their headquarters and to Congress about what education is accomplishing. But it also, we really enjoy it trying to get all of these different people interested in ham radio. You know, a great many of our schools will end up with amateur radio classes. And sometimes they'll even go for a grant to buy equipment and they'll end up with a club and station of their own after one of these contacts has happened. And a survey we did a few years ago, or actually I think NASA did this survey to find out what the teachers, educators involved thought of the program. Everybody seems to like it. And you probably don't need to read all those, but basically some of these slides were aimed at our people who don't know anything and might be wanting to work with us. We blow our own horn a bit. On a more interesting note, we've got or have had radio stations in the ISS in 3 different locations. The FGB was the first module launched. It was built by the Russians. And it had a small VHF antenna on board to use for docking when the service module was launched, which was the second module to take place. After those docked, that antenna had no purpose. And it was close to the 2-meter band, so the Russians let us use it. And when the first crew went up to the space station, 1 American and 1 Russian, they took a little handheld radio and a box with a power supply and TNC in it. And that was the first payload that they hooked up when they got there. It was working within a few weeks of their arrival back in November 2000. And in December 2000, we did our first school contact using that equipment. And this is kind of what it looked like. In the upper left of that inset picture, you'll see a vertical black thing. That's the handheld radio. It was made by Ericsson. And to its right is the white box with the power supply. And if we had a closer look at it, you'd see all the TNC lights on it. After a few years, we set up a modified D700, not very modified, but we had some custom frequencies programmed into it. And we also set up some antennas that we had built, a set of 4 of them. And those were installed during spacewalks around the outer edge of the service module. Let's see. So this is a supply ship. This is the service module here. And our antennas are located at 90-degree intervals. And there's one there, and then the 2 corresponding spots on the bottom. And once those antennas were in there, we set up the D700 radio and hooked it up to it and started using that instead of the handheld in FGB. So that radio looked something like this. It was mounted up on the wall. You can tell this is the Russian module because they've got all these pictures of people like Chief Designer Korolov and Konstantin Tsiolkovsky, who is in Russia considered the father of spaceflight. He was a very advanced thinker for his time. But he came up with something called the rocket equation, which is still used today to figure out weight to fuel ratios and things. And of course, Yuri Gagarin was up there. This is one of the astronauts who was really active on ham radio. His name's Mike Fink. And on his 2 tours up there, he would get on the radio a lot in his spare time and just talk to any hams who happened to be listening. And then one of the last modules to go up was the Columbus module up here. And that was built by the European Space Agency. It had 2 L and S band patch antennas installed on it on the ground for ham radio. And then once it was up there, they installed another little whip antenna for UHF VHF, which is located down near the bottom here on the trailing side. And we pulled that handheld radio out of storage and put it in there until just a couple of years ago when our latest radio system was set up. And that looks like that. It's a D710G radio with a ham designed power supply on it for it and all sorts of other equipment that we hope to have up there. So it's a nice little place. Because the 2 modules are at opposite ends of the space station, we can run both radios at the same time. And just in case you've ever wondered, this is the front end of the space station down here. It's going that way. With all the radios, we can do voice on VHF and UHF. We can do slow scan television at times. We usually do that in special events. We had an amateur digital television transmitter up there for a few years, and then it failed. We were able to get it brought back to Earth and repaired. It took another few years because the pandemic slowed things down a lot. But right now, NASA has it back. We're expecting that to be launched in May. I haven't heard an exact date, but we've got our fingers crossed. Okay, rather than just rest on our laurels, so we've got an endeavor we call ARTEMIS 2.0 going on now, which is to expand our operations, provide new capabilities, and give us some educational programs that can operate without astronaut presence, because astronaut time is expensive. We're very fortunate that we get as much as we do. We try to not overuse that. So what we're going to be doing is all those things. One of them I already showed you there, the new radio system, which gives us the 24/7 operations. 24/7, always with an asterisk. As I mentioned, there are safety considerations during an EVA or sometimes when a spaceship is arriving or departing. The radios have to be shut down. But aside from that, they're always up, they're always running. And with the voice repeater, if an astronaut is interested in just talking in his spare time, all he has to do is turn up the volume, pick up the mic, and get on there. I'll be talking about most of these other things later, the different educational programs, Axiom. There's a little more about the new radio system. We called it interoperable because there are basically 2 different power systems on the space station. And we built this so that it can plug into either one and provide us everything we need. 13.8 for the radio, 6 volts for a little SSTV unit we have. It's an old Kenwood product called the VCH1 that doesn't exist anymore, but it was neat. It's kind of like a speaker mic, but it had a camera and display on it. So you could capture pictures and send them out in SSTV. We built a total of 11 of those units. There are 2 on the space station. There are 2, actually they're still here behind me. They're flight backup units. If we need to send a replacement up, it'll be one of those. And then a lot of others for training and testing. We have them dispersed all over the world. That first radio was launched right before the pandemic, March 2020. And the astronauts got it installed in September of that year, and it's been operating ever since. The second one in the Russian module was launched early in 2022, last year, and a few months later it went on the air. So it's been since May of last year, we've had the two radios both on, one running a voice repeater and one running the packet digipeater. And just because we like so much to look at this, I've got a number of pictures of it. This is where it's located in the Columbus module, up in a corner near the hatchway, which is in the lower right. A little closer look at it. I can tell from the display that it's currently in packet radio mode. And another close-up. We put tags on the power supply to thank some of our larger donors, our development team. And on the other side, something commemorating the IORS and the memory of Ham, who was a big supporter, Bill Tynan, who's also a past president of MSAT. On the educational side, one of the things we're working on is something called the Student Mission Control. That's a project that the ISS National Lab initiated. They're working on it with University of California in Berkeley and with ARTEMIS. You see, Berkeley is building basically a student mission control website, and ARTEMIS is building a sensor system that's based on a Raspberry Pi. It will go on to the space station, and we'll use our radios to send that information down. It will be stored in a hub, and students can use lesson plans created by Berkeley to go in and look at that data and answer questions, or maybe solve, feel like there's a problem, look at this data, see if you can figure out what it is and what to do about it. I haven't seen any of their license plans, but it'll be things of that sort. It should be a lot of fun. It's another look at how it will work. The data can be captured by our ground stations and by SatNogs. It has a very extensive automated ground station system, and any telemetry that they capture is automatically stored out on the web on one of their servers. So it's readily available for projects like this. And the sensors we're planning are the ones in green there on the left. We, in addition to all the different kinds of sensors, we're hoping to build in the capability of controlling the Kenwood radio. So if we can get access to it through the network on space station, then we could go onto the web, talk to our Raspberry Pi, and change the mode in the radio when we need to and not have to ask an astronaut to do it. That sometimes can take several weeks to get communications and get time for them to go over to a radio and make a little change. We've also been working with Axiom a lot lately. This slide was to kind of explain why we're doing it. You may know that the space station is scheduled to come out of service in the year 2030, which is only 7 years away now. That time goes very quickly. And for my own part, I'd be surprised if they don't get extended again. It's already been extended several times. But eventually there won't be an ISS up there, and we need to have some way to keep our programs going. in space. Axiom is currently the most active commercial company doing that. And they flew their first private astronauts last year, the X-1 crew. 2 of them did ARIS contacts while they were there. They have another mission scheduled to launch sometime next month. Still waiting to hear exactly when. And we know at least one crew member on that one is interested in doing some ARIS contacts. In fact, he's somebody who has had a ham license independent of the ARIS program. Most people use our radios to get their license before a flight just so they can do that. This guy had one when he was young, and I think there was a break, but he's got one again. Axiom is also designing some modules that they have an agreement with NASA to let them attach to the ISS. So they will be building the beginning of their own space station attached to the ISS. And when it is finally deorbited, they will just detach and stay in space and keep building it out. So we are hopeful that we can get our ham radios on board that in the future and continue the kind of operations we've been doing and have it available for hams. Different educational programs that we're working on, again, to extend what we can do. Stereo is a big one. It takes a radio kit that we've been working on for a while and adds teacher education. We hope to provide one of these radio kits along with training to every school that does an ARIS contact once we get started. It exists. We've been demonstrating the SPARKI kit at ham fests for a few years now. If you've been to Hamcation or Huntsville recently or Hamvention, you will have seen parts of that on our tables. We've worked with teachers. In addition to the ARIS team that does the operations and works with schools for the technical things, we have an educational team as well. Teachers, most of whom did a contact of their own for their school. And now they help other schools with the educational side of doing a contact. So they have helped put together lesson plans, and we'll be providing that. A Raspberry Pi with an SDR, a lot of software, the keyboard and display that you see, and the electronics kit for building circuits. All of that is a package that will go out. We did our first train the teacher meeting. It's not a webinar. I was about to say so many things are, but this was a face-to-face meeting with 6 or 8 teachers to give them a couple of days to play with this, to learn how to use it with their students and as part of their educational programs. And that will be done on a regular basis, initially in the US. We hope to extend that to the rest of the world too, with translated lesson plans, but that's going to take longer to work out because, as you can imagine, it's a little more complicated. And we also need to come up with volunteers in different parts of the world to assemble the kits and ship them. If we tried to ship everything from the United States, the price would go up considerably, or the cost of doing this. Another program we're working on is STAR. And that basically provides a small programmable robot and the means to connect it to a computer by Bluetooth or to connect it to a radio. Well, it would still go through the computer. So we come up with lesson plans for that as well. The kids learn to program the computer, run it around their classroom. Then they can cooperate with other schools in their area and send those commands over radio or phone or whatever means they have, or computer network. And the ultimate challenge is to send those commands via APRS through the digipeater in space on ISS or on another satellite, and control the robot at some other school going through an obstacle course or whatever has been set up and described to them. So they need to figure out what the commands are and then get those commands all the way to the robot. Our little bit of introduction in how to send something to Mars. And a few more pictures. There's our new radio system again. This was last year when Chell was working on field day. And I'd like to see the log, the list of call signs that he's got clipped there.
November Alpha 1 Sierra Mike 0 Lima Mike Kilo.
Mike 0 Lima Mike. Call sign. Say again for NA1SS.
Mike 0 Lima Mike Kilo.
Mike 0 Lima Mike Kilo. This is NA1SS. Welcome to the International Space Station.
November Alpha 1 Sierra Mike 0 Lima Mike Kilo. My name is Isabella. I'm 8 years old. You're 5 and 9. Thank you.
Mike 0 Lima Mike Kilo. This is November Alpha 1 Sierra. Isabella, it's so great to chat with you. Thank you for getting on the radio and saying hello.
Thank you. Fly safe.
Thank you, Isabella. 7-3s.
I would have warned you that was coming, but when I was going through the slides, it didn't do that. So that was one of the contacts that Chell did. He liked radio when we get on in his spare time and talk to folks on the ground, and he got surprised by that, just as the ham, who's Isabella's father, got surprised too. But it turned out to be a really fun contact for both of them. You could hear Chell perk up when he found out just who he was talking to and how old she was, and that got picked up by news services all over the world. It got a lot of publicity for amateur radio out of it. One other thing that's coming up in the future is getting out of Earth orbit. We're in talks with NASA to get some ham radio equipment on the Lunar Gateway. It's still very early days, so there's no telling if it will actually happen, but we want to see it happen. They're interested in having it happen, so we'll see how it goes. It's going to take a lot of changes to the way we do things. Different modes of operation. It'll probably be digital because we will be mostly using antennas that can't track the Earth as Gateway circles the moon. But it looks doable. So stay tuned. That's going to be very exciting. One of the early prototypes we came up for it was a box that's going to sit outside on the Gateway. She'll have an enclosure for the electronics and an antenna and some cameras on the outside that can be controlled from the Earth. Gateway is not scheduled to be occupied all the time. In fact, there'll only be astronauts on 1 or 2 months out of the year. The rest of the time, it's all going to be automated. So we need to work that into our plans. Then we'll have a radio, or basically a headset interface inside that the crew can use to talk on the radio. And with all that we're doing, we've got lots of opportunities for people who'd like to have a hand in something. Working with NASA and getting things designed is a lot of fun. Working with the school groups and actually seeing the kids responding to hearing the astronaut's voice come back for the first time is just hard to describe. A lot of fun. So we've got a lot of jobs we can use people for. Electrical and mechanical design, especially with these new projects coming along. We lost our mechanical designer a while back. Bob Davis was a very talented ham doing that sort of work. He died a year or two ago, unfortunately. A big blow to ARIS and AMSAT and really any of the ham space efforts all over the world. You could contact me or go to one of our websites to volunteer or just get more information. A few more pictures of all the kids, some of the kids we've talked to, the way they gather, nice small groups, sometimes whole auditoriums and entire schools. Those are our two websites. ARIS.org is the international website. ARIS USA is for our US team and also covers the legal details for the things that we need to post for our organization. But that's where you go to get information on doing a school contact in the US. We're also on lots of different social media. Basically look for ARIS or ARIS International in some form. And a bunch of frequencies where you can use the repeater. These are all on our website, so you don't need to scramble to write it all down. And that's it. I'd be happy to take any questions.
Would you be so
from,
kind, please, as to put your contact information slide back on? I couldn't quite get to it in time.
Okay. The websites?
Just before that, you said, I thought there might have been a slide with before that one, maybe.
There was just this one and the social media.
Oh, okay. All right. I'm sorry. My phone was down and I thought you thought there was another. Thank you.
That's okay. If there's anything else you need, just ask.
Okay. QRZ as far as your call sign, if we want to send you an email.
That would work. Yes.
All right. Thank you, sir.
Actually, W8AAS at almost anything. At AMSAT, at AMSAT.org, at ARL. What do they use? Net? I don't remember. And I do have something on QRZ, so you could find me there too.
Very good. Thank you. Wonderful presentation. Thank you for your time, sir.
Thank you. Okay, I think I shut that down. Is everything back to normal?
You need to unshare.
Oh, yes, right. Unshare, stop share. There it is.
There you go. Terrific presentation. Thank you. So anybody have questions for Dave? So I have a question. Can I start this off?
Sure.
So we're going to have the Scouts at Field Day. And it would be nice to have some sort of a introduction to amateur radio in space. Do you have a teaching module or any kind of guide that could help us with that?
Not just right off the shelf, no. We could probably, let's see. I'm trying to think of what I've heard from people who've done things.
Yeah.
Somebody might have a presentation that would be along the lines of what you need.
Yeah, something just to introduce, you know, the whole concept of amateur radio in space, plus just a space shuttle. You know, kids love that kind of stuff. It's exciting, you know. So anything that just
I'm thinking, if you go to our YouTube channel,
yeah,
we've got a number of introductory videos on there. I haven't looked at them all, but I've seen the names, and as I recall, some of them might be what you're looking for.
Okay.
And that could help.
Great, thank you.
And if not, get back in touch with me, see what I can do.
Thank you. Any other questions?
Okay, if there's no other questions, that means I talked too long and said too much.
No, it means that you covered things very well. Oh, Eugene, did you have something?
Yeah, I was wondering, in terms of like doing things that would normally be simple for us, like putting antennas on the outside,
Uh-huh.
what is the process for like running coax through the or other connectors, like through a bulkhead in a 0 atmosphere environment?
You work with NASA many years in advance, or with whoever's building the module, and arrange for feed-throughs to be built in.
Okay.
And that's what we use. The Columbus module had a number of feed-throughs for exterior antennas and sensors, and we had negotiated to get the use of one of them. Actually, we've got the use of 1/4 of one of them. It's a big connector that has 4 leads coming through it. So we are one of them. And that's for our VHF UHF antenna on the Columbus module. There were a number of feed-throughs on the Russian service module that were designed for this. And when we set up the 4 antennas, they had feed line attached that was pre-cut to stretch from wherever that antenna was going to be on the space station around the perimeter of it to the feed through and to come inside. And then on the inside, there were connectors, and you'd send up some coax along with the radio to be plugged into that. They put our 4 antennas on in 3 different spacewalks.
Wow.
Okay. All right, since there's no more questions, thank you, Dave. Thank you for your time and for your expertise and all that you do to bring amateur radio to a whole new generation. Thank you.
Thank you.
All right. So, unless there's anything more, does someone want to make a motion to